Hello everyone, this is Subhashmita Majumdar from IIPS DABV Indore. This is a question that is given for our NAD internal. NAD is like numerical analysis and design, and the question given was obtain Simpson's rule using Newton Cote's formula. Now the solution, if we start with the solution, Newton Cote's formula can be given by this formula, fx integration from a to b equals to nh summation of yi ci to the power ni from 0 to n. This is like equation 1, where ci to the power n is equals to 1 upon n integration of lix dx, where in the limit stands from a to b. Now if we change the value of x here, which is substituted as a plus hu, and if we substitute the limit as a, x equals to a, then we find out that u is equals to 0. Similarly, if we differentiate this equation, that is x equals to a plus hu with respect to u, then we see that dx equals to h du, and at x equals to b, which is our second limit, u equals to n. Now lix equals to x minus x0 into x minus x1 till x minus xi minus 1 into x minus xi plus 1 up to x minus xn whole divided by xi minus x0, xi minus x1 into xi minus xi minus 1 into xi minus xi plus 1 into xi minus x to xn. Now if we substitute x as a plus hu like we have been doing here, so you can see that this above equation changes in this form, and again if we substitute lia plus hu, this whole equation turns into this form, that is u into u minus 1 into u minus I minus 1 into u minus I plus 1 into u minus n whole divided by I into I minus 1, I minus 1, I minus I plus 1 into I minus n. Now deriving Simpson's 1/3 rule using Newton Cote's. For this we have to put n equals to 2. So when we put n equals to 2, the integration changes from a to a plus 2h, like you can see here in this. If we put n equals to 2 and b has been changed to a plus hu, so like you can see that this integration now changes to 2h summation of yi ci to the ci square, where I is from 1 to 2. So the equation changes in this form, like you can see, and this is our equation 2. Now if we calculate individually the values of c0, c1 and c2 square, so c0 square is equals to 1 upon 2 integration of L0 u tu from 0 to 2. co square, now if we actually solve it out, then we get 1 upon 2 integration of 0 to 2 u minus 1 into u minus 2 upon 0 minus 1 into 0 minus 2 du. Now c0 square, on solving and putting on the limits, that is 0 and 2, we get equals to 1 by 6. And similarly if we solve c1 square, we get the value of c1 square as 2 by 3, and similarly we solve for c2 square and we get the value of c2 square as 1 by 6. And now we put the values of c0 square, c1 square and c2 square in equation 2. So we get the equation, this is our equation 2. So we get it as 2h y0 1 by 6 plus y1 2 by 3 plus y2 1 by 6. And this integration that we initially had, f of x from a to a plus 2h equals to comes out to be h by 3 y0 plus 4 y1 plus y2, and hence the above equation shows the Simpson's 1/3 rule. Now to obtain Simpson's 3/8 rule, we put n equals to 3 in Newton Cote's formula. So again with the same integration, that is f of x a to the power a plus nh equals to nh summation of yi ci to the power n I equals to 0 to n. So we initially put 2 here, and now since we are substituting n as 3, so we put 3 here. So the equation turns out to be this, wherein only the n has been substituted as 3, and this is the equation 3 that we get, that is 3h y0 30 cube plus y1 c1 cube plus y2 c2 cube plus y3 c3 cube. And now if we calculate individually the values of c0 cube, c1 cube, c2 cube and c3 cube, we get c0 cube as 1 by 8, and we get the value of c1 cube as 3 by 8, the value of c2 cube as 3 by 8, and the value of c3 cube as 1 by 8. Now therefore c0 cube equals to 1 by 8, c1 cube equals to 3 by 8, c2 cube equals to 3 by 8 and c3 cube equals to 1 by 8. Now putting these values in equation 3, we get this equation. So we finally get the result as f of x integration limits from a to a plus 3h equals to 3h by 8 y0 plus 3y1 plus 3y2 plus y3, and hence this equation is the equation of Simpson's 3/8 rule, and hence we prove the Newton Cote's formula is applicable for deriving the Simpson's rule. I hope this lecture was very beneficial for you. Thank you. Have a nice day.